Alright, this second rule is really important for the rest of calculus, so really make sure you're paying attention. This is just saying that the integral from a to b, which are, again, both constants, of f of x dx is equal to uppercase f of b minus uppercase f of a. And uppercase f of x is just any antiderivative of f of x. So that means that the derivative of uppercase f of x is equal to f of x. So because of this relationship here, because uppercase f of x is the antiderivative of f of x, if we want to take the integral of f of x at a certain point, we get uppercase f of x at that point. And to find the integral of f of x between 2 points, like we do here, a and b, then you subtract uppercase f of x at the first point from uppercase f of x at the second point. So it's uppercase f of x at the second point minus uppercase f of x at the lower point, or the first point. And this right here is what's called a definite integral. To really understand this, we need an example. So we're going to use the example of the integral from 0 to 1 of 6x squared dx. Alright, so now this 6x squared is our f of x. Our a is 0 and our b is 1. And we need to know what uppercase f of x is, so we can do this. So to find uppercase f of x, we need to find the antiderivative of f of x, which in this case is 2x cubed. And we know that's the antiderivative because if we take the derivative of this, we get 6x squared. And we'll go into how to do that quickly in just a minute. So now what we're going to do, to say that we're evaluating it between these 2 points, we draw that line and write a 1 and a 0 for the upper and lower bounds. Now the next thing we do is we take this equation here and plug in 1 and 0 for x. And remember, we do the upper bound first, so we plug in 1 for x, you get 2 times 1 cubed, and then minus uppercase f of x, because this is our uppercase f of x right here, this is our antiderivative. We subtract uppercase f of x at the lower bound, 0. So 2 times 0 cubed, that's equal to 2 times 1 minus 2 times 0, which is just going to be 2. And that's how you solve a definite integral. Alright, so there's a quick tip to finding simple antiderivatives like in the problem we just solved. To find uppercase f of x, the antiderivative, using the original function f of x, you have to learn to do the opposite of deriving, which is why integrals are called antiderivatives. For simple integrals, like in the problem we just solved, we add 1 to the power and then divide by the new power. So our f of x was 6x squared, right? Now the first thing we do is add 1 to the power. So that becomes 6x cubed. The next thing we do is divide by the new power. So 6x cubed over 3 is equal to 2x cubed. So that is our antiderivative f of x from lowercase f of x, our original function. And that's just a quick way you can do simple antiderivatives of really easy terms in polynomials like that.